How's it going, everybody? Welcome to the stream. Today we're going to be doing some tuning. Kind of walk you through if you've just got a printer up and going, or you've had a printer running for 10 years and you want to run through tuning stuff from the very basic beginner stuff all the way up to through the intermediate into the advanced, and then chasing unicorns. Whatever you want to do, we're going to kind of touch on all of that. And with me to do that, we've got none other than Reth himself, the master of all things input shaping.
Oh, no. It's way too much credit, but thank you. Happy to help out.
We've been actually having this discussion recently, in the last 24 hours, about how actually since the weekend, really, right? You're so incredibly knowledgeable that it doesn't matter how much you know. As soon as you start talking to you feel like you know nothing. You feel like you're Jon Snow, right? And you do it in such a way.
You're being way too kind, man. You're being way too kind.
But this is what we were discussing, right? You do it in such a way that you're never talking down to somebody, right? You're never condescending about it. You're like a teacher in front of the classroom that's sharing information and that wants others to be better. And I think that's fantastic.
Well, it is kind of selfish, though, right? Because I'm doing it also to figure out what I don't know, so that I can help other people more.
Yeah, and this is a conversation I had with my daughter last night, as a matter of fact. All right. So this week was state testing for her. And Tuesday, she had the first part of math. And she did incredibly well. And then Wednesday comes along and she just hit a brick wall. And was struggling, right? And I told her, I was like, how's it going, Luke? Welcome.
Doing good, doing good. How about yourself?
Pretty good. For those that don't know, this is Luke, aka Digital Dragon, on Twitch, YouTube, and North Carolina
and
retail.
About everything else, yeah.
But yeah, I was like, look, like, use this as an opportunity. Now you know something that you didn't know it before, right? And figuring out, finding the things that you don't know is the first step in that journey to bettering yourself, right? Use it as an opportunity. But let's see, who do we got here tonight? We've got Jeff, Reth, of course, Raj, Vince, How We Do It, aka Brad, Heidel, welcome. Captain Kern raid, nice. Welcome everybody from Captain Kern stream. Yeah, Brad, Reth did shave. It made it extremely hard to find him on Saturday.
Nobody knew who the hell I was.
Yeah. And Cody, it was good meeting you at Rocky Mountain. So, Luke, as I was just explaining to everybody, what we're going to do here, we got to try it. Up and running. I did some initial tuning stuff, but what we're going to do is we're going to use it as an example platform to run through the things to do when you've first built a printer and beyond for tuning. I'm sure somewhere along here we're going to run into something people have never done before, right? Or learn something to push their tuning above and beyond. Pat Racer, how's it going? It is hot in my garage. Last I looked, it was 90 something. What is it in here? Yeah, 91. So you'll forgive me if I am constantly drinking something.
You gotta get some AC in that garage.
I do. I need like a mini split or something.
I'll forgive you for drinking a Capri Sun instead of drinking coffee. I'm at least inside in the AC.
It's coffee all day long, man.
I would kill for a nice coffee right now. Very large iced coffee. So we're going to add to the scene. We're going to add, this is the main sail interface for the Trident. And then we're going to get just a camera view of the Trident so you can kind of see what's going on with it as we do this. Luke and Ref are comfy. Yeah. They don't look like they're sweating at all.
Nope, not at all.
They're cheating.
I have a fan blowing on me right now.
I got a very large fan right up here.
In my office.
You do not want me to turn it on. It's a big industrial fan. Steve 3D Builder, welcome. All right, so Reth has also been kind enough. Reth, do you want to share your screen, because you've shared some different documents and PowerPoint stuff with me before. I can pull them up, or you can. It's up to you.
As we talk about them, I'll pull them up and go over them, the specific slides in them. But okay. Is there anything? I mean, yeah. Whenever you say, "What should I do?" I can pull something up.
I was going to start off with just a brief overview of the list that you just sent me, like the order of operations.
Yeah. Let me do that. Let me find that.
Because the order that you do this stuff in matters tremendously.
To a degree. To a degree.
Yeah, some of them can be swapped, but...
So this is a talk I gave at Portland Vice on how to create your own slicer profile. So you built your own printer, you got no idea where to start. How can you do it just from the graphs from Input Shaper, and get close enough to then start doing prints? So the order of calibration, E-steps is one of those things that can go anywhere, because it's not reliant upon anything else. It just needs to be done before you start printing. I recommend doing belt shaper, input shaper, and vibration profile all first, even before you do pressure advance. And that's because the max Excel that you're going to set for your slicers is going to affect your pressure advance. So you're going to get a different pressure advance if you're printing your perimeters at 1000 Excel versus 10,000 Excel. You don't need to get them perfect at this stage. All of the input shaper, shape-tune stuff, you don't need to get it perfect. You just need to get it good enough, and then you can move on to the print. And then after that, you can go back and kind of fine-tune it if you like. So after that, then it's just straight into slicer setup, and first layer. EM and PA are another one of those things that can be swapped. They do rely upon each other to a degree, but you can swap them back and forth. For example, Ellis Print Guide puts PA before EM, whereas I believe Orca, the tests go EM then PA.
So I was going to say, just one thing real fast, is the assumption that we've gone through initial, I'll say like bronze style commissioning checks. Your motion's good, your end stops and everything is good. You've got your initial belt tensions set, because once again, any of that is going to play in at least with your belt shaper and stuff like that. And then E-steps, I will say you need to do before you start doing any of your printing tests. Because once again, if you go through and you do your extrusion multiplier in PA, and then you go back and say, my prints are still looking funky, and you do EM, you got to at least start back over at that stuff. And at the very beginning commissioning of a new print or a new printer, yeah, don't expect your belt shaper and input shaper to be 100%. And not only that, but you're breaking in the motion system. After a few hundred hours, all of that's going to have to get redone anyhow. So,
yeah, I would agree that it is. This order of calibration I have is after all your mechanical checks, 100%.
Yeah. Yeah.
And the belts. Go ahead.
This is all. This entire thing is assuming that the printer's mechanically functional and you're ready to get ready to actually start pushing plastic.
Right. Your belts don't necessarily have to be 100% at this stage, because as I'm sure Digital Dragon, you'll go through this once and then you're going to do it again, and you're going to do it again. So although there are no arrows, this is not a flow diagram, because we tried to make one, and it just balloons up, because a lot of these stages you go back to the beginning, and you're 100% right that as it breaks in, your belts are gonna maybe expand, maybe stretch a bit, and motion systems, your motors will kind of get worn in a bit, and things will change on you. Just because you run it once doesn't mean it's static now for the entire life of the build. So I would agree with that. But creating that flow chart would just is a nightmare.
Yeah, I kind of use it as a OODA loop. You just kind of cycle back around, and then you cycle the same step over and over again. Just your first one, right? You're tuning E step. So you're going to run a test. You're going to see where you're at. You're going to make an adjustment. You're going to check it again. Make sure if you're good now, great. If you're not, you're going to do it again. You're just going to keep doing it until you've got it right.
Looking for, though, in at least the input shaper stuff, you're not looking for perfection. You're looking really just to kind of rule out mechanical issues.
Yep.
And so you can fine tune it later. You can adjust certain things later, but at the initial order of this calibration, you're just really looking for mechanical issues that are showing up in your belts and input shaper.
Yep. And we're going to be able to show you some of that today.
Oh, I should stop sharing my screen.
So, through the initial setup, we do have E-steps, rotation distance, all that kind of stuff. However you want to define it, depending on what firmware you're using, that is set up on here. So we're going to start off with step 2 of doing the belts. If I'm assuming most people watching this are going to be running Clipper currently. So with that assumption, most of your extruder options have published very, very good rotation distance settings and all that, as well as most of your builds have all that kind of stuff. It's pretty standard on most printers. You're either running 16 or 20 tooth idlers. I think some of the Kraken motors were coming with 40 tooth pinions, but I don't know anybody that actually ran them. So most of that stuff is very well documented, very straightforward. You're going to get past what, E-step thing very quickly. Now, what I want to show is, well, the software we're going to be using for a lot of this is Shake and Tune.
I will say there are other other tools, non-clipper tools, right? There's one called Res Helper that I know of. And what that does is it does one function that Shake and Tune does, is in that it uses the actual damping ratio derived from the graph, where Clipper defaults to a 0.1 damping ratio. But it doesn't have necessarily all the other bells and whistles that come with Shake Tune. So that's the other big one that I know people use.
So this is a pretty straightforward install. You're just going to SSH into your host, probably using a Raspberry Pi or similar. You're going to run one line of code once you've SSH'd in, and then you're going to copy and paste this into your config, and then you're good to go. All your macros are going to be there, everything you need. It's a very straightforward install. On their docs, they have instructions for the different commands and whatnot. But
it also, in the documentation, gives you some examples. So it's a pretty good, the documentations on it are pretty good, I would say, for the examples and what things are. It doesn't necessarily tell you how to fix it or what's the root cause, but it does tell you kind of the general idea of what's going on.
Yeah. So once you've got it installed, in your macro section, you're going to have axis map calibration, axis shaper calibration, compare belt resonance, vibration, create vibrations profile, and excite axis. I think
the axis shaper is actually input shaper. So I get confused on it too when I'm looking for the input shaper button. It's called axis shaper. Mm-hmm. So just that's it. But the axis map, you don't necessarily need to run. It's the one that allows you to put in the resonance on the ADXL section, the axis for the ADXL, so that way the graphs show up and that X is X and Y is Y and Z is Z. Because depending upon the orientation of your ADXL, the graph, the subgraphs will show up as different colors representing different axes.
Yeah. Now, you can have multiple ADXLs.
Oh yeah, but not in Shake Tune. If you're gonna, go ahead. I'll probably cut you off.
As you can see here in the config, under resonance tester, I have both of
Alex,
my.
Can you make that bigger?
Is it Control Plus? Yep.
Yeah, there we go.
Yay. So, you have resonance tester. I have both of them defined in here, and then I just comment in and out which one I want to use. So, the tool 0 is going to be the one that's on the tool head itself on the O2S board. On this one, it might be an EBB 36 or whatever you happen to be running, a Nighthawk, etc. And then I also have my ADXL on the beacon. For today, we're going to run all these using, well, we're going to start off with the beacon. We might want to show how you're going to see different graphs depending, but we'll get there.
If you want, I can show what they look like from different positions.
Yes. Yes.
Yeah, it's kind of interesting too, because the placement of your sensor is going to have a result on your graphs, and the closest you are to your tool head is going to, or excuse me, your nozzle is going to be, give you the most accurate reading for the actual print. So a lot of times our tool head boards are up on the tool head by the extruder. Your beacon probe is at least down near your nozzle, but it's off to the side and it's normally hanging on a piece. So it's how rigid is the sensor, how rigid mount is it, where is it in relation to your nozzle. Yeah, and it's all going to impact that graph that you're going to see.
Yeah. Now, Reth will
goes
be able to.
It actually goes further than that, though, right?
Yeah.
So your nozzle location has all those considerations, but it also you have to take into consideration what you're looking for, right? So if you're looking for mechanical issues in your printer, you are not going to use the nozzle, because most nozzles act like a pendulum, so you'll get an extra peak, and actually I'll show you in a bit here. You'll get an extra peak from the nozzle going back and forth. So if you're looking for mechanical issues, your best bet is actually the tool head board itself. And then if you're looking for a final print, like what is actually going to be in my print, that would be the nozzle. But these commands I'm showing here are both Calico and Clipper allow you to simultaneously measure all the ADXLs you have on your printer at the same time. And you can graph them independently, or you can graph them combined. So this is the compare belts test. You just kind of list them out here, all of them. Input shaper is the same way. And then you end up with, this is the different graphs. So on my, printer, this Trident here, this is my Nighthawk, this is the Carto, and this is the resonance nozzle, which is the nozzle itself. And you can see how each one of them reads it. And then you combine them. You can also break it out. So this is input shaper with sweeping. And you can see what each ADXL is seeing. And then this is the Y shaper. So you can kind of see that the Nighthawk gives this extra stuff here. The Carto gives something here, and you get something here. And then once you combine them, you get a combined view if you like. So I think there's a better one. Yeah, so this one is, okay, this is without sweeping, so sweeping off. You get the belts, which are all fairly the same. Differences are going to be in your power spectral density. I find that the Carto and the nozzle, the resonance nozzle, have a lower power spectral density. And then the X, they're about the same. There's details are different inside of it, but about the same shape is what I'm looking at when I say about the same. And then Y, and you can see here on a pulse, when you're using pulse, so sweeping's turned off, you can see that this peak right here and this peak a little bit here have really become more pronounced from the nozzle to the Nighthawk. And so this is some of the testing. I did this on multiple printers. I ran this on ShakeTune too, but in ShakeTune, it doesn't have the capability yet to run them all at the same time. So you had to run them differently, which you start talking about run-to-run variations and stuff like that. But it followed the same general pattern. That Carto will give you something like this, the Unicorn, the resonance nozzle give you this, and then the Nighthawk gives you this. So chasing mechanical issues, this is what you would want to use, because here what you're really chasing is the nozzle itself and how well attached the nozzle is or to the rest of your tool head. But they're all attached the same way, right? We use 4 screws on everything. So this is a known phenomenon in our current standard V6 nozzle that it will do something like this. Not much you can do about it except redesign the nozzle tool head.
Yeah. Real quick, I'm going to address some
Sure.
comments in chat here. Acidfly Studios says that this has convinced him he's not ready to build his own printer. Sounds like you need a college degree. No. Stay tuned, because we're going to get to the basics that are probably going to be good for 95% of people doing a printer, and it is super simple, one line of command, and then you just click save config and go from there. So I promise you, the basic entry level, good for 95% of people, is super simple. And then Jeff says that as a note, you have to have an accelerometer installed on your machine. or you can't do this input shaping. That is correct. However, most people right now that have built a printer have a toolhead board installed, be it EBB toolhead, a Nighthawk toolhead, a Orbiter toolhead board, Mellow Fly. Most of those have a accelerometer built into it. If you go into the documentation for your toolhead board, there's a good chance that when you go to the config section that they've got built out there, the generic config for it, that there is a section called ADXL, or what's the other type of sensor? It's not an AD.
LIS2DW.
Okay. So you're probably already covered, but if you're not, LDO offers a ADXL chip. You install that. Again, there is one line of code. It's on the Clipper docs to enable input shaping. What is it? It's called Numpy or something like that.
Oh,
and then you just attach it to your tool head and you're good to go. When you're done running your input shaping calibrations, you take it off. It just attaches with a little ribbon cable and you're good to go. I think that is like under 20 bucks from LDO.
I think it's like 15.
And for everyone here that is kind of freaking out about this stuff right here, any commercial printer that you buy that's got Clipper on it, that has an input shaping or auto calibration feature, it's going to run input shaper because it has an ADXL sensor on the toolhead board, and it's running that one line Clipper config that basically says do the access or input shaper and then save the config values, and it's all done in the background. So it's doing the exact same thing we're telling you here. It's just shielding you from the geek and the graphs and all that stuff.
Yeah.
On the market right now that could do the excels they're advertising without it.
Yeah. I'm going to show you one more thing before we get started on this. Under Resonance Tester, there's a good chance that this in your config, this section here, the Excel per hertz all the way down to sweeping period is not there. This is extra stuff you can add and define stuff. Otherwise, Clipper has a default setting that it's just going to default to, and Clipper now defaults to a sweeping period versus a
pulse.
Just sitting there vibrating super hard. And that's going to be defined here. So this just gives you a little bit more fine control, and that's what Reth was talking about with sweeping versus pulse. If you set this to 0, it's going to pulse. Otherwise, and Excels per hertz, you're probably not going to run that at 125 for your.
You're going to want to run it if you got a Voron, you're going to want to run it higher than the default 60. 60 is too low.
Yeah. So I think you said before 100.
75 to 100 for a default Voron is good. All-wheel drive, you're looking at starting at around 125.
Yeah.
If you go too high, so say you just say, oh, I'm just going to hit it to 200, expect screws to fall loose. You hit a point where your accelerations per hertz is how much energy you're putting into the system, or the printer in this case, to get your measurement back. And if you're too low, you're not going to be able to resonate the printer. If you're too high, you're well past the energy it needs to get a readout, and now you might see screws fall onto your bed. It happens. So you really don't have a need currently to go above 150, even with the 40/40 extrusions and stuff like that. You hit a plateau where it makes no sense.
Now I'm gonna start off here. We're just gonna start with the very basic input shaper command. So you're gonna want to start off by just homing your printer. Ideally, you want to make sure that your printer is sitting wherever its home is going to be. You don't want to do this on your dining room table and then go move it onto your shelf in the garage. Because the surface
that's a good test. So Yamamoto and Avor on Discord did a test, and he put a printer on a very solid foundation, like a very solid table or on the ground even, and then he moved it to a really super like cheap wobbly table, and his results didn't change.
Interesting.
Yeah. What we deduced was that it doesn't matter necessarily the surface that the printer is on. What matters most is how well you built it and how solid it is built together. So we do ask people sometimes to put it on the ground and see what changes, because it might show that maybe they need to tighten the frame a bit.
Then once you have it home, shaper_calibrate. And you just hit enter, and you are going to get your printer running basic input shaper. It's going to take a few minutes for this to run, so while it does that, we're going to be here to entertain you and answer any questions you may have. If not, we'll just talk amongst ourselves about things that only we care about and you don't. So feel free to post questions. But
yeah, you've probably got noise filtering on, don't you?
No. Yes. Yes,
yeah,
indeed.
it's always nice to hear these things and how much they start shaking at resonance. And I know I've freaked the wife out a couple of times for starting to run one of these things on like a Trident 350 on the dining room table, and she's sitting in the other room like, oh my God, what's going on?
Yeah. Now, this is on pulse right now, but sweeping is way quieter. It does not shake nearly as much. And that is stock now in Clipper. So if you're running this and you haven't changed the sweeping to pulse, it's going to just be sliding back and forth across your gantry a little bit.
Sweeping will so once again, it's what you're looking for in this test, because sweeping will hide mechanical issues you may encounter, because it will smooth them out. Is basically what it's doing. It was designed for printers that were not well built. So think of like your Ender 3s, bed slinger style. And so they were getting all like very bad results, and they couldn't actually figure out what shaper. So Clipper created a sweeping to take care of that situation, to get them at least a solid good peak, or the attempt to. So it all depends on what you're looking for, on the settings on that.
Yeah. Now, for those that did not see the podcast where you talked about it, do you want to tell everybody, because you mentioned it was you're going through your graphs, the Rethinus nozzle?
Oh, yeah. So, as Digital Dragon said, for printing, potentially, the nozzle is your most accurate of what's going to happen on the print. And we were looking around, Sidonian from E3D and I at last Rip Rap Festival were talking about this. Like, why isn't there an ADXL that actually measures the nozzle? And so, years passed, and then we got to it. So E3D is going to come out with their version of the Rethinus, and LDO is going to come out with their version of the Rethinus nozzle. One will be a Revo, the other will be V6 style, and we figured out a way to make that ADXL board so small that it fits inside the nozzle. So the nozzle itself is your ADXL, and currently we know of no other way to measure it. Do I have a picture of it? Yeah. I'll share my screen again and show you what it looks like. Alex, can you share the screen so I can show what it looks like?
Sorry, I was.
Yeah.
Jeff, your EBB 2209 toolhead board does have an ADXL on it. I just sent you a link to the page with the config. You're looking for lines 16 through 21.
Yeah, so that's the nozzle right there. And it just screws on like a regular old nozzle, comes with a control board, and you can measure. I do not know of anything more accurate for a nozzle ADXL. All the other ones are a board you use your current nozzle to screw into. And we've seen issues with that because sometimes the cable will interfere with the readings and stuff like that.
This is pretty sweet. I saw it at in person at Rocky Mountain. Reth was kind enough to show it to me, and it was even on display over at the E3D booth because you're working with both LDO and E3D on this, right? LDO is going to do the V6 style, and then E3D is doing a Revo style.
Right.
So that's going to cover probably, what, 90+% of people's hot ends.
We're talking about we can send it to everybody else's hot ends and figure out how we can do that. Because some of these things like are super tiny nozzles.
Yeah.
The board we've designed, while it's super tiny, it's still going to be bigger than some of the nozzles out there. I can't hear Digital Dragon at all.
Sorry with me. I assume anything that can support an M6 thread, even if it's a super volcano size, you can still screw this in. But it's the stuff that's using the M4 thread, like the Bamboo Lab nozzles and stuff like that, you wouldn't be able to do unless you use the M6 thread version.
We haven't actually looked into it, but I've seen some of the nozzle sizes, and we'd have to figure something out. Yeah.
All right. Now, once you've run shaper_calibrate, you're going to get this where it says the save_config command will update the printer and save the config. And if you just type in save_config and hit enter, you can be done. And that's going to get you most of the way there.
A lot of people just hit that.
Yep. I did that for years. So it will get you where you need to go pretty much all the time. Now,
and this will, for some of us, we'll try and chase the rabbit, so to speak, down the rabbit hole. And every time you make a change to that machine, whether it's adding bracing or, I'm gonna change the tool head and go to something else, you have to rerun these, and you just keep chasing it and chasing it and chasing it. And at my point, I just say, kind of the heck with it. On a lot of machines, I rebuild it with the latest set of mods I'm throwing on it. I run input shaper, and then I start pushing plastic.
We call it chasing the unicorn because you're chasing the single peak.
Uh-huh.
Yeah, you got to know when to stop. That's the hardest thing for some people. But some people, they love doing this. They just want to keep tweaking on the machine, like
Yep.
the what was it? What was that '70s show? The Brady Bunch, right? Where they'd always fix their bikes but never ride them.
Yep.
It's is this your hobby? That is the part of the hobby you love? Then all right, fine.
Yeah.
But if you like printing, you can just do it once and see where it's at.
Yep. And then from there, you just continue on down that line list of order of operations.
What do the graphs look like, man? Come on now.
Does it produce graphs with Shaper Calibrate?
Oh, yeah. You gotta do the
Yeah.
You have to convert it yourself if you do Shaper Calibrate. If you use Clopane, it will.
So what we're going to start with is the first thing on your list is the belts. So this is part of Shake and Tune. This will create graphs for you, automatically save them into a folder. It's compare belt responses, right? It is going to compare your A and B belts. We'll start that running.
It will also do Core XZ, which is nice. So like a switch wire. It will individually vibrate both the X and the Z belt, so that you can figure out how to tighten your on your Core XZ on your switch wire.
Nice. I need to try that. I've never really messed with it too much on the switch wires at all. They don't print fast enough. I don't know. I've never messed with it too much on them at all.
Yeah. For the currently the belt tensioning on a switch wire basically sucks, I think. So you can get good enough. That is one I definitely do not chase.
Switch wire, I just take the PF makes meter out, make them both about 2.2, 2.3, whatever number the first belt ends up on. That's why I make the second belt, and then I'll run input Shaper on the x-axis. Maybe I'll pull out my independent ADXL and throw it on the bed. Maybe not. Who knows?
I throw it on the bed because that's an easy one to tension on a switch wire, because the input Shaper is the belt, effectively. You can also use it for that. What tool do you like to use, Digital Dragon? Do you like the built-in clipper, or do you like the Shake and Tune?
I've used them both, and I think I like Shake Tune, simply because it auto-generates all the graphs and everything for you, and it puts it in one place. Doing it the other way, you have to go and do extra steps to generate the graphs, and it's just a bit of a pain.
Acid Fly. So what input shaping is all trying to do is to knock out the resonance. So if you see ghosting, or if you see ringing on a print, and it's just some feature, it's going to be kind of replicated multiple times. What it's doing is it's inputting pulses into your steppers as they're moving to cancel that out, so that you get really clean lines. Without input shaping, you would have to drop to 1,000, if not less, in your accelerations to remove a lot of this ringing, because your tool head is a mass, and it's moving at a certain speed or velocity, at an acceleration. And just like when you get in a car accident, you hit a wall or hit another car, it just stops. Your car stops. Well, when you change directions or on your tool head, it stops, but then it kind of vibrates with that stopping. So what you want to do, and then when you take off, it's like you're in a car and you take off real fast, your head gets thrown to the back. It's the same thing's happening with the tool head, effectively. So if you can throw input shaping in, what you're doing is you are canceling out the tool head's vibrations as you are accelerating and decelerating. And it has a limit. You can't say I want 100,000 Excel and expect perfection. And all the graphs, both Clipper and Shake and Tune, will give you kind of like a max recommended Excel of what they can do to cancel that out. But the negative is if you go too high in your Excels, yeah, it may cancel out the ghosting, but then it introduces smoothing. And what smoothing is when you look at the back of a Benchy, you have the lettering there. If you have too much smoothing, that lettering is just going to be turning flat. It'll get rid of all the detail. And so that's the negative of being overly aggressive with your accelerations, even using input shaper. So there's a fine tuning, or you want to kind of set your slicers in your Excels for the quality of the print that you want. And, it's a visual thing at that point, not a structural, not a, my print's going to fall apart. It's all visual. I hope that explained his answer or his question. Yeah, how it's a balance. It's a balance. So the other variable, you've seen it, it's called jerk. Orca calls it jerk. Other people call it, Clipper calls it SCV, square corner velocity. They're not the same. So jerk is the derivative of the rate of change of your acceleration, whereas square corner velocity in Clipper is how fast you're taking a turn that's 90 degrees or less, right? So how sharp of a turn are you doing? They're effectively the same if you can think of them. But if your square corner velocity is too high, your acceleration at some point, the acceleration recommended by Shake and Tune will drop. So if you want to have a 100 square corner velocity or something like that, Shake and Tune will tell you, well, your max Excel is 0 because it can't do it. You just broken the math. So also, when your square corner velocity gets too high, yeah, the input shaper may be able to handle it, but your smoothing goes through the roof such that your corners are no longer sharp. They start rounding. And it ends up starting to look like a PA or a pressure advance issue. So when you're setting square corner velocity, I think Orca personally is a little too aggressive in some of their values. But you got to take that into consideration. Like, why is this corner not sharp? It could be that you've set your square corner velocity too high.
There's also a minimum cruise ratio in Clipper too.
I got no idea what the hell that does. I set that default.
So default is 0.5.
0.5.
Right? And as I understand it, and as it was explained to me by the Clipper guys when they first changed it, because it used to be max Excel to decel. It is the percentage of your straight line movement that is spent decelerating. So 0.5 means 50% of your straight line movement is spent decelerating back down to whatever you're going to take your corner at. On this particular machine, I've got it at 0.25, but well, we'll get into, you'll be able to see in the graphs some of the issues that are going on in this printer right now. That definitely needs to be changed. It mechanically cannot do it right now. Okay, so after you've run these, you're going to have the outputs to a folder. To find that folder, you're going to go into machine, and you're going to go into Shake and Tune results. We just did belts. Sorry, I gotta bring this size down a little bit so I can read this. Okay, so this is our newest belt compensation. Estimated similarity 95.1.
Don't look at that number. Never look at that number. It's there. It's there as a reference. It means absolutely nothing.
That's good to know. See, I'm learning today.
That's the opening to that hole I was telling you about. And every time you try and make a minor adjustment to bring that closer, it just seems to get further apart.
Yeah.
So the most important thing on this graph, or this whole graph, is the two graphs, and that's really it. What you don't look at good mechanical health either. That doesn't mean anything. What you are looking for is on the left-hand side are you generally will get two peaks, and you want the both belts to be on top of each other. And what you want on the other one, on the right hand, the cross belt comparison, is you want the graph to be in that flight path there, the green area. If it's not in the green area, but the other side looks fine, leave it. So what you have here, okay, so this graph will only tell you relative belt tension. It will not tell you mechanical issues. It may hint at some, but it won't tell you that. So what I see here is potential that you may need to tighten your belts a little bit more. Because if they're too tight, you'll see a different version of this.
So let me ask you, gentlemen, and we'll ask chat too. Do we want to make an adjustment so we can see the difference that an adjustment will make to graphs, or would you rather just continue on down the line of, what you do, or do you want to see like the just noticeable difference? Rest Comcast internet has struck. Brad says make an adjustment.
Yeah, I'd make an adjustment, and Mad Dog Jeff, up in the top left of the belt frequency profile, you will see which belt is belt A and which is belt B. Remember your Vorons, the belts go bah, like a sheep. So B is the belt that goes around the left rear motor pulley. A is the one that goes around the right rear motor pulley.
So, frequency.
So how close, well, let me rephrase that. How do you tune your belts, Alex?
Normally, so on a normal Voron 6mm belts, I'll go tighten them to about 2.3 on a PF makes meter.
Okay. And that's what I was going to ask is, are you using some type of tool, like the physical metering tool, like the PF meter, or are you doing a resonance strumming type thing?
Oh, God, no.
Yeah. I tend to do the resonance strumming, but it depends on when you're doing it and how much ambient noise you have.
This is the meter.
Yep.
You see, so right about there is 2.3. This is a much different gantry. This is 9mm belts. This is Vitali's rigid metal gantry. Now it's important to know that past 3 on this, you start going exponential. These belts are tensioned to about right here. So, well, it's going to be rather difficult, but I'm going to try to put this meter on our belts here. Let's see where each one of these is setting. This one's at just over 3. That one's right about the same point. So these have lost some tension since I built the printer. It's got about, I could check, but probably about 10 to 15 hours on these belts. So
Acid Fly, yes, those tools can be printed. You can also purchase that tool as a pre-built tool from companies like West 3D. There are versions that I think BQ sells that are made out of aluminum. So it just all depends. Hey, Reth. Yeah, stupid Comcast.
did it automatically put them back in, or? Oh, no, it's in chat. Well, we're almost there.
Yeah, Ruth and Down Under Maker. I normally, like I said, I normally strum them. It's move the gantry around, center the tool head in the middle of the gantry, pull it all the way to the front, take it back to 150 millimeters between the front bearing pin and the front XY pin, and then strum on each side. Try and get them as close as you can to the same value, and you're looking, I believe it was 100 hertz right there for a 6 millimeter belt, and then that's a good starting point. And then every time you make a belt adjustment, you take your tool head, move it around, and then do the same thing. Center it, pull it to the front, move it back to 150 millimeters, strum. It's a bit of a pain in the butt, but I think you get a little bit better and closer side to side.
So we've got that belt calibration running again. And then we'll see where that goes. Hopefully Reth can get back in here. Reth, is your internet going to allow you to rejoin us, or is it said no?
If it's Comcast, it probably said no.
I do not miss Comcast.
Yeah, we had Kinetic by Windstream at the house, and it was the only option I had. It was that or satellite, and I refused to do satellite.
Oh yeah.
And as soon as another option came in, and it was Spectrum Fiber, I was like, I'll dig the trench for you, install it. And they got it to the house, and they're like, our installer will be out in a couple of days. I'm like, I got a guy that did fiber for a living. He can, he can terminate this in a heartbeat. But yeah, it didn't take me too long to jump on that at the house.
Yeah, I've been really happy with Frontier Fiber. I've got 1/2 gig symmetrical.
Yeah, the best one I had was Ting Internet synchronous fiber, gig up and down. And I had one issue with it. They came out, and when they had wrapped it up in the box on the outside, apparently it wound up snapping. And as the guy had redone it and was sticking it in there, he felt it snap. So he had to redo it a 3rd time. But 3rd time was a charm, and I had no issues, no internet issues at all for like 9 months. And then we moved out here into the sticks again.
Yeah. When I went looking for a house, part of the requirement was that there had to be access to high-speed internet without a dish. Where I was at previously, I had line of sight high-speed internet, so there's a dish and it's got line of sight with it happened to be a farmhouse at the end of the road a couple miles down, and like it worked. I was able to stream stuff. I think I had 12 meg download, and I don't know, maybe 1 meg up, but it worked enough for me to be able to stream YouTube and stuff like that. And then my in-laws ended up getting the same thing, so we had 2 connections because was not trying to share 12 megs with somebody.
Yeah.
But yeah, moved here is Spectrum. I had Spectrum for a while. Started out at 100 meg, then they increased it to 200. Well, no, at my last house it was Spectrum too. But then Frontier started running fiber lines, and I was calling them every month for a year plus, like, have you run it over my way? Have you run it over my way? And the nice thing is it's only me and my neighbor on this like leg of the fiber, so.
Yeah, we saw them running fiber, and I knew exactly what it was, right? I knew they were running fiber out here, but I couldn't get anybody to tell me who it was that they were running fiber for. And finally, I got one of the workers and was chit-chatting with him, and he finally told me who it was for. And I was like, thanks, man, because now I'm going to start hounding them like on the daily.
Yeah.
When are you ready? When are you ready?
That's what made me so mad. So, where I had that line of sight, they ran fiber all the way up that road, through the front yard, to the like middle of town there, because it's just a little town. Like there's literally one light in that town. But they would not branch it to run to any of the houses down that country road that they were running through the front yard. We didn't have an option for them to dig a hole through our front yard, but you know, they weren't willing to run it to us.
Yeah.
Think we're almost there.
Think so.
They didn't say that my back looks weird. Does my back look weird?
Oh yeah, you got a little bit of scoliosis like me, Small. Welcome to the Future Back Pain Club of America.
Nobody tell me that. How bad is it?
It's not bad. It's not letting you back in. Let me create another. Copy.
So, Alex, when are you going to start, or have you started your stealth changer build for Howie?
I have started. Panels showed up today. No spoilers on those, but they are sick. I was going to do a stream yesterday if they showed up yesterday, but they didn't. They didn't show up till today. So we'll do the Makers Making podcast tomorrow night, and then I think we'll do a special Saturday stream.
Okay.
The little one's got to go to a birthday party, and I'm hoping that I can just send the larger one, the middlest child, to supervise that situation, and I can come home and do a bit of a stream. But we were waiting for the bottom panel because that was the next step.
Okay. Yeah, like I said, mine's mechanically together. I just need to start all the calibration stuff, and it's just sitting right here within eye shot, staring at me every night.
So here's our.
Better.
Yeah, it's a little better. Wrath, is that link working for you?
And which belt did you adjust?
Both of them. I tensioned both of them.
Tension both of them. Okay.
You get no connection, but your internet is working again.
Okay. I'm going to have to step away for just a second. The FedEx guy just pulled up.
All right. Try closing out your Chrome browser and reopening Chrome. So on the PF makes meter, we are sitting right about there. Yeah, right about there. We were at 3 on the meter, and now we're at what would be like, I don't know, 3.3 or something, too high. Remember, this is Vitaly's RMG. It's the 2-wheel drive RMG. I'm going to regenerate this URL. Let's regenerate it. That should refresh EVMux's stuff. See if that'll work to let you back in. Okay, so where are you thinking? Like 2.5 or so? Because we were at 3. Go all the way down to 2. All right. Move, disable steppers. Oh, this thing is so hard to read when it's upside down. Where are we at? We're at 2.5. .4.
Mommy says I can't go outside. When is this spring about to get over? Mommy, when is this spring about to get over? I want to go outside and go on my poker stick, but Mommy keeps saying no.
Well, why can't Sissy take you outside to play on your pogo stick?
Because her have to do chores once it's stupid.
Okay, well, it's nowhere near 7 o'clock right now.
No!
Why can't Smalls take her outside to play?
Come on.
All right, we're almost there. Says you are expired. All right, let me try. Copy. Paste. Try that one there, Reth. .1. That one definitely needs tightened up some. We're way below. See, Lauder, how's it going? $2.4. $2.4. All right, we got down to 2.4 here. All right. Damn, right. Can't really get because the RMG, the belts are separated by like 2 millimeters. There's not enough room to get in there. All right, let's drop out of here and run the belt compensation one more time. Oh, we're gonna need to home it first. Hi, Con. How's it going? Hey, Reth, you can join from a phone, by the way. I don't know if you've got a phone or an iPad that has service, but it'll let you join from there. Oh, they're probably just extrusions people cut. All right, running this again.
All right, looks like I will join from the phone.
Welcome back. I was getting worried.
I was getting worried. I thought I was lost, man.
I can't do this without you.
So scared. I don't know what to do.
Yeah, so that was my misunderstanding then, just from chatting with people in the beta for this. I thought I needed to tension these up way higher than that. I didn't realize that.
So for all-wheel drive, you tension it perfectly. That would have been great values. But for two-wheel drive, if you tension it too high, what can happen is you'll get the graphs you got, and then what you'll start seeing is more VFAs.
Okay. Makes sense to me.
Hi, Digital Dragon. I got back. I got found.
Yeah, no, my FedEx guy showed up, and he's like my crack dude right now, bringing me printers and stuff for the store. So
I didn't get to see the end of your stream. For those that don't know, both Digital Dragon and Reth have YouTube channels. If you're interested in any way, shape, or form in what we're doing today, you definitely need to go subscribe to Reth. And then Digital Dragon builds printers like I do. owns a shop, so you get to learn some of the ins and outs of being a supplier in the industry. And you were working on a Cheaty last night, right? How'd that end up?
Well, I mean, it's actually sitting over on the line right now. I told it to print boat, and it printed boat. So I'm not sure. The story that I had gotten was that it sounded like there was a nozzle jam, and the customer wanted to return it. Now I got it, and it still had all the customer's information on it. So the first thing I did was try and do a factory reset on it. And we got it tuned and loaded filament, and it loaded right up, and I printed a print. And I was like, So now I'm staring over at the Keedy box that came with it and wondering if there was a filament path issue from the Keedy box into it that may have been causing them issues, because there were a lot of multicolor files, like keychain type files on there. So I need to take that out and throw that on there and take a look at that.
Reth, your channel is called The Original Reth, right?
Hell if I know. I think it's called, I don't know. Yeah, The Original Wrath. Yeah.
Hey, Free Heathen, how's it going?
Oh, forgot. Let's see.
Everybody gets to see all the channels I subscribe to.
Dang, dude, I thought I subscribed to a bunch of channels. Yeah, I just got in some other Keedy Tech printers today. Q2s, Q2Cs, Q2C combos. The big
How are those
ones
printing?
I'm sorry?
How are they printing?
Oh, they print great. I love my Q2s. I've got the actual display printer on my line for the Q2 and the Max 4 are my personal printers that I've purchased. And I bought them because of the chamber heaters, and they have the ability to print, polycarbonate, PPS. They're not going to do peak. They're not going to do Ultim.
Do you really need those?
No. I mean, the ability to print PPS for some of the builds that I do, and the ability to do nylon consistently is going to be good. We're doing, especially on the Max 4, I've had 3 different people that do auto customizations that have come in and bought printers from me to do auto customization, whether it's full single dash inserts, or I've got a piece over here that I printed out for a customer that may be coming in from Myrtle Beach and buying a couple of printers. And he wanted to know if he could print his files out and what it would look like. Well, there's an armrest for a custom armrest for a Fox body Mustang. I did have to break it up. It is going to have a couple of seams filled. But yeah, this is ASA printed at 0.16 layer height, and I don't know why my camera is doing the blurred stuff. But prints beautifully. This guy's coming in from Myrtle Beach to get some fabric because he does custom upholstery work as well, and he'll probably
if you're putting fabric on top of it, do you really need to fill the seams in?
Probably not. And that's the thing, is it depends on what he's going to do with these as to whether or not, how much body work he would really do on this. But this was basically to show that he would be able to print these out on a Max 4 with minimal requirements for later on. And he may wind up buying some because the cost of having injection molded molds created to injection mold these, it's just going to increase the cost of the finished part way too much.
Right.
And I mean, see, that's the thing is 3D printing is really great for doing that customization, doing those one-off prototyping. I was just watching a video by Vision Miner and talking about tooling jigs, right? If you do any type of line assembly work or any type of building whatsoever, like I've talked to several of the construction companies around here, any type of repetitive task, 3D printing is great for building a jig to make that repetitive task a lot easier and a lot quicker and more consistent. Gives you better results over time. And the ability to quickly iterate and make changes to those jigs, because in Vision Miner saying they were talking about auto manufacturers, and they're going out and having tooling molds made, and then they have, we need to make this tweak or that tweak. Now you're sending out for another $10, $20, $30,000 mold being created, and 6, 7, 8 week lead time, and that's time that's impacting your production capabilities. They can do that in house, iterate, print overnight, and the next day they've got a new jig that they're working with, right?
No, that makes sense.
Yeah. So what'd you do here, Alex?
So we took the belt tension back down. It's at right about 2.45 on a PF makes meter.
Yeah. So that peak, what is it, 5 and beta 2? That's starting to see what it should start looking like. But peak 1 is a little off. I would bring it down more, but I don't know if you can, because you probably pre-tensioned it, right?
Yeah.
Yeah. So it's going to be the only way to redo it would take the tool head off and let off some slack on the belts and re-go back that way.
Yeah, I can see if I can get any more out of this.
But the other thing you can do is, let's run input shaper. Let's see what it looks like, and we can get more information that way.
Yeah.
What do you think, Visual Dragon?
I'm sorry, what was that?
What do you think of his Mr. Graphs there?
Yeah, I think he definitely needs to focus on belt A, and I'd probably say loosen it slightly if possible. Leave belt B alone.
So this is like the hard part of belts, right?
Yeah.
It's which one do you adjust? Because sometimes you can say, okay, well, let me loosen belt B, which is the purple line. And what happens is A goes off and does something else.
Yeah.
Because the belts in the core XY are not individual belts. The XY joints couple them together.
Yeah.
So if you change one, it has an effect upon the other.
That is correct.
So it's always like the first time you make an adjustment, say this is the first time we're looking at this. When you make an adjustment, pick a belt, make an adjustment, and then see the effect. And if it's not the effect you want, put that belt back to where it was, and then do the other belt.
Yeah.
And sometimes what really sucks is sometimes you just have to redo it.
And this is where having a notebook and taking notes, and I've talked about that before, but I don't do it consistently. But I tell you where I did do it, when I built the black box. So the black box is a water-cooled 5-head tool changer, and it was my first time building a tool changer, my first time building anything that used Duet hardware. And when it came time to start doing the calibrations, Dude, there was a pad and I had notes scribbled everywhere. And every time I thought of adjusting something, I was like, okay, let me cross correlate what that may do to this, that, or the other. Because my biggest fear was driving that thing, negative Z China into the build plate and really, really wrecking it.
Yeah. I think I just rely more on the shake tune, the fact that shake tune can save your graphs.
Yeah.
And I don't know, okay, quarter turn here, okay, let's run it. Or whatever whatever it is, I only have to go back one step or one graph. So I don't think I've written down, took notes with my stealth changer, but that was only for like the X, Y, and Z offsets, not necessarily the belts.
Yeah, exactly. And that's the part there is, the belts, you get them close, and at some point you have to say, okay, we're close enough. I'm done chasing it. Let me just push plastic. Because once again, if it's a brand new build or you just rebelted it, the belts are going to change after a couple of 100 hours of print time, right? Push plastic, enjoy it for a little bit, break it in mechanically and everything, and then, go ahead and chase some belts and fine tune it. But, the biggest thing on a stealth changer or any type of tool changer is getting those XYZ offsets just right. That's what you want to chase, because that's going to give you the biggest quality difference. Right?
One thing that can happen though, if your belts are, say your input shaper's fine, both of them, but your belts are slightly off, or not slightly off, they're off. One thing can happen is, depending upon the angle that you're printing, you could see VFA show up on one side or the other. That's kind of a negative. So sometimes you're chasing, VFAs, which are the vertical lines that go top down, and they're not ghosting, so they're not necessarily repeating and then diminishing. They're just constantly there. You can see VFAs on one axis, which are the diagonals, more than the other if your belts are so far off. That can happen.
Yeah.
I've got this down to 2. We'll see what it says, and regardless of what it says, we'll carry on to what to do next.
Okay.
I got a box of candy that I like to, right by my desk. It's probably going to give me diabetes later.
I normally have a bag of assorted Hershey's Kisses. So
I just ran out of Hershey Reese cups in the refrigerator today.
Uh-oh.
I had 3 at the start of the day. What I need is water, though.
Woo. Yeah, go grab some water. Stay hydrated.
Unfortunately, my Rocky Mountain cup did not have the straw in it, so.
You need to share them with the group. Knocking things over.
So, I'm assuming you're going to have a booth at Murph, right?
I'm going to have a table at Murph. I don't know if it'll be an official Digital Dragon 3D booth, or if it's just going to be a Digital Dragon 72 table. Partly because I don't, I may bring things to sell, but don't expect me to be bringing a bunch of Kitty Max 4s for sale, because I don't want to carry those things.
Well, I tell you what, worst comes
Hot
to
ends and
worst, you
stuff,
don't have to
maybe,
carry them all the way back. You can drop them off here.
Oh, is that what I need to do?
Yeah. That way you
Yeah,
don't have to
I'll probably
unload them when
bring.
you get home. I'll unload them.
Yeah, I'll probably bring a bunch of like the tool heads and stuff like that. But
Do you have a website?
I do have a website,
What is it?
digitaldragon3d.com.
Okay.
Yeah. So we've got a bunch of the Fadus lineup of hot ends and nozzles, to include the Dragon Ultra High Flow, the Rapido 2s, and the Rapido 2s are the higher temp versions. And then we're going to be bringing in, I just made my first order, we're going to start carrying some Honey Badger fans, the Alpha nozzles,
Okay.
and we're going to be starting to bring in some of the rails and stuff, but I have some PEI sheets coming in as well from them.
Cool. What do you
Yeah.
find that people in hot ends? What do you find people are gravitating towards right now?
You know, I have not sold a bunch of hot ends, and that's partly because I just found out that a lot of them weren't published to the website. So as I was going through and doing some database cleanup last night, I realized that they weren't published to the website. So I had to go and fix that. But bring one Kitty combo, you'll take it off my hands. Which one? Message me and message me and we'll figure that out.
So what is your? I'm always interested in this and because I'm in my own little world with Voron printers. But
Yeah.
what do you find a lot of people are gravitating, or what do you sell the most of?
So originally the first vendor I had in printer wise was FlashForge, and the FlashForge 85X is a killer printer to get people into and get them started. You get the color, and you're getting the color in at like a 340 price point, and the IFS will do flexibles.
Okay.
I have run a lot of TPU prints through the 85X and their IFS system. It's the only one that I know that does it reliably. The Keaties, I have had a real hard time keeping them in stock. The ones that I've had a hard time, or the ones that I've had in stock the longest has been a Max 4, because people are wanting the Max 4 combos, except for the folks that are just out there printing, like I said, car parts, because they're like, we're just going to run ABS or ASA and call it done, right? At that point, the Keaty box just gives you the automated failover. But when I had the Bamboo H2D here, they would walk in and they're like, I'm looking for a Bamboo. And then they immediately go, what's that?
Okay.
So the Max 4 is 390, 390, 340. It beats the H2 series size-wise every day of the week. And you can't print like a full-size dash on an H2. But you can over on the Keaty Max 4. So, but yeah, I've sold a lot more of the Keaties. So.
Okay. Are they just? Why do you think that is?
I think price point and the quality of the prints that we're getting off of it. It might help that I've got a aircraft carrier sitting over there that was primarily printed on the Max 4. And everybody goes, wow, this thing is awesome. And I was like, yep. And everything but the multicolored deck panels was printed on the Max 4. And the only reason the multicolored deck panels were printed on the H2D was I was running out of time. It was a gag gift for one of our D&D guys. He was a Navy guy that spent his entire career in a basement teaching new Navy recruits. So we had to show him what a boat looked like.
Alex, what did you do to get this graph?
Took the belts down to 2.
Okay. So, both belts?
Yeah.
Yeah. Are your belts even?
Yes.
And you have same amount of teeth on both sides?
Yep.
You got racking going on?
That was a pain in the butt. I didn't. I can check now, though. Let me see. Disable.
Yeah, you can just check to see if there's a bounce on the front.
No.
Like you'll hold one, and then you press the other, see if it bounces. If it doesn't bounce, then you hold that one, and then you press this one, see if it bounces.
No. Nothing.
Nothing.
And you've checked, and none of your belts are dragging anywhere or riding up on a flange.
Yeah, I'd run an input shaper and see where you're at there. Let's see. Like your B belt is starting to look like it's supposed to.
So, Reth, you mentioned that you have a stealth changer.
I do. I made a 6 tool head version. Too much. Too many tool heads. Too many tool heads.
So it's a 350?
It is a 350, yeah.
All-wheel drive or two-wheel drive?
Only 2-wheel drive.
Okay. I've got the LDO all-wheel drive gantry on my 300 with 4 tool heads.
So. Yeah, I need to rebuild mine. But when I do that, I'm going to drop it down to 4, maybe even 3 tool heads. Because what I found is that most colored prints that I print, the 4th color is usually reserved for like a sparkle in the eye or something like that.
Mm-hmm.
And to me, that's a waste of time for the print. So I just make it all one color. So I might drop it down to 3 tool heads, because it's a stealth changer or a tool changer is a lot harder to keep going than something than a regular single head tool printer. And the calibrations, when something goes wrong, take a lot more time.
Yeah.
So especially, I don't know about something like a snap maker or something like that. That might be easier. And I don't have the most recent tool changer software, which I know the calibrations have gotten easier. So I just want to restart and do it again. At least the tool head portion.
Yeah, and I think, with the snap maker, you've got the FlashForge Creator 5 and 5 Pro that's coming out, which is another 4-head tool changer. And then you've got Solvals. I think as we see more of those commercial ones come out, we may see some additional. I'm hoping we see more stuff come out on like the Voron and other custom build stealth changers like Black Box. Like the Black Box, I did use. There's a Z pen that gets all of the Z heights the same, and then I use the CXC camera to get all the tool heads adjusted right. But my God, that is like fine tuning to the nth degree to try and get it there.
To get the prints to line up.
Yeah. And then, like I said, you sneeze at it, or in my case, you pick it up, you throw it in your truck, you drive it a few hundred miles up to Murph, you throw it on a rickety table, and then you try and make it print and look cool for people, and then you chase all kinds of things there.
Yeah. I mean, they can be a little bit more temperamental.
Oh, yeah. Especially a water-cooled one.
I was talking to Alex earlier. I was like, I'm looking forward to the index and to see how that gets calibrated, like on a Trident, and because I got lots of Tridents that if I could turn them into multicolor with that, it'd be really great.
Yeah.
So that's what I'm looking forward to next, because I don't know if you know this, but I run a nonprofit called 3D Printing Elves.
Okay.
And so we print toys for kids, all year round. And what I'm starting to discover is that I need to focus more on having like a single base of printers.
Yes.
So like, while this other printer may be great, I'm not going to buy a whole fleet of them. And if I just have one of them, then it's more parts I have to stock. Because at least in all my Vorons, except for the linear rails, everything is the same. I can just start, stock the same fans, because when something breaks, I don't want to wait, a week to get another part.
Well, and the nice thing with Vorons too is it doesn't matter if it's a 2.4 or a Trident. You can send the same sliced file to it and it'll print it. Right?
Right. Except I tune my profiles too much.
Time, and that's fine. My mini print farm that we have back here, I've got 6 Centauri Carbons and 2 X1Cs with AMSs. So I use the X1Cs if we're doing something that we know is going to be over a kilo, so it can do the auto failover, or if we have to do something in color. But like right now, I'm building the Tyler mobility trainers from Make Good, and I can have all 6 Centauri carbons going because all the files are on there, and I can just start printing them in succession, right? Now we're seriously considering selling off the Centauri carbons and putting all Q2s in the back. Just because, once again, consistency. Stock the same parts, and every file I slice can go on any printer and print. So, yeah.
Yeah, my other consideration, though, with not going to more commercial printers is the cost, right? Cost and time. So for me to get a part and to repair a Voron, it's a lot quicker than a single source for a commercial product. And what I've found is that over time, a lot of these commercial products, like take, for example, bamboo, a lot of their screws screw into plastic. And you only get so many times to screw a screw back into plastic before it's done. And so for the Vorons, I can get the part, say a fan, maybe cost me, I can go cheap and get when someone put it off Amazon that'll get the job done, or I can go buy an $8 fan or whatever it may be. I can get it back up and running really quick. And I know if I take that fan off today, or if I take that part off today, a year from now, I'll still be able to screw it, unscrew it, and not break anything. And I know the part's still available in the future.
Yep.
Because I can't afford to throw away a printer and buy a brand new one every time,
Yeah.
Luke, did you see the new? You were talking about carrying Fadus. Have you seen the new Rapido that they've got?
Yes. I am trying to get them. It's the Rapido X.
Yeah.
You may need to upgrade your power supply to run it.
Yeah, what are they, 120 watts or something?
Yeah, they're definitely more than a 60-watt heater.
Yeah.
You want to know something else that'll require a different power supply? Come on, focus. There we go.
Let me make you big here.
Yeah.
What is that?
This is a Takato. You can get them from all 3DP, and I believe Luke's Labs has them as well. There's a short version, but this is the long version. This has a super volcano nozzle in it, and each one of these heaters is a 100-watt full-length super volcano. So there's the heaters right there. So these heaters are full-length 100-watt super volcano heaters, and that is a hardened steel, I believe, 1.2 millimeter nozzle.
So what would you need that for, right?
I have a 600 cube printer coming to be able to do some very high-end high flow items. So I can't talk too much more about that, but yeah, I do have
because there's the
some things coming in
tricorn
where I may
with
need
3
it.
heaters.
I'm sorry?
There's like the tricorn, I think it's called. It's got 3 heaters in it.
Yeah. Yeah, there's a couple of different ones out there, but this one is definitely going to require me to have its own heater just for this. I gotta figure out how I put the, oh, it's got it. There we go.
So here's our graphs. This is for the x-axis.
All right, I see. It's not bad. It looks like you might have a screw loose and a little bit of binding.
Yeah. And then this is the Y. Our shark teeth are still here.
So that little hump before, so it looks like you might have binding on this one. That'd be the low frequency stuff, 0 to 25. And that little hump could be also a loose screw, but the junk on the back from like peak 3 to peak 8,
Yeah.
I'm not sure exactly what that is. Go back. Can you go back to your X, please? I'm not sure why. Your X. Okay. So you might be riding on flanges somewhere in your gantry, because the 0 to 25 again, that should go flat and then up like a slope, and you're going the opposite way. And the 0 to 1, the 1 to 2, I'm pointing at my monitor and you can't see. The 1 to 2, it's okay to have that little second hump on number 2, but because you have a divide there, it should be connected. It should go up and then maybe a little hook and then smooth out. You usually see that up higher with a loose screw or something loose in the tool head. So I would be looking at the tool head for all this. The lower frequency, 0 to about 25, I would be looking at the belt path and making sure that's all correct and everything's flowing smooth. The higher stuff may just be resins vibrating off of the other stuff in there.
Yeah.
Because I didn't see any Z's per se. It's all X or Y movement, it looks like. And I can't share my graphs because they're on I got a folder on my GitHub, and it's called How to Read Input Shaping. And all of the data we were able to gather so far, and still gather, we put a graph up and we say, look, these are probably what's causing it. And it's kind of like a picture match, a matching game, if you will. But the other stuff is generally something. I mean, I would start looking around for belt bindings. Something's not running smooth. Something's a little maybe. And plastic XY joints would be a metal. I'd be the plastic clamping on it, but that's what I would look for.
Yeah. Now, as we've discussed, and I'm currently trying to get it sorted to get some in, because they're not cheap. But the rail, specifically the X rail on this thing, is trashed.
Well, if that's trash, then
yeah,
it's going to throw everything. If you know you have a crunchy rail, there's no point in doing this, right? Because even if you are able to get good graphs, the crunchiness is going to show in your prints, right? You're the little tiny balls will show up as they're going across the crunch. They'll show up in your prints because the whole thing will go boop 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 boop, and then
But so for those watching, we knew that rail was an issue. Could not get anybody. I was hoping I'd be able to pick one up at Rocky Mountain. Nobody had rails at Rocky Mountain. Checked with Hector, checked with Dan. They had already departed by the time we figured this out at the end of the week. So there was no way for them to bring rails. Currently in discussions with Hector to get his ultra lightweight rails that are, they seem like they're like the equivalent to like the Motion Perfect ones from West 3D, but they're kind of skeletonized out the back and stuff like that.
They were nice looking.
They're nice rails. So working on getting new rails for it, but the exercise of what you go through, the steps that you take, still apply regardless of whether or not we can necessarily perfect this thing today, right?
And this shows the hard thing about asking for help troubleshooting, because all I get to rely on is the graphs, right? If I and Digital Dragon 2, we're looking at the graphs. We're not at the machine feeling how things are moving. And feeling like, oh, when I go this way, it's fine, but when I go the opposite way, or I'm moving in Y, I'm getting this. So that kind of information, a lot of the troubleshooting on this requires kind of you have to be an active participant when you ask for help in input shaping.
Yeah.
Because just showing a graph and saying, what is this? I'll never be able to tell you. Because I'm not there feeling it. Now, if I was there feeling it and say, oh, yeah, it's probably this, that's a different story. But that's, I'm 1,000 miles away.
Yeah. But, again, like I said, we knew this going into it. This wasn't necessarily a help me fix my printer. This was more of a help everybody else understand the steps that you're going through, what you do, and I
was just talking more of like if you're reaching out on Discord or Reddit or something like that, just some situations you can look at the graph and say what it is, but other ones like this, like your Y with all that craziness happening at the end, there's just no way someone's gonna be like, oh yeah, it's this, on that, because once again, we're not there to feel it.
So it's a good example, right, of what to look for beyond just the graphs, especially if you're picking up a used printer. I know a lot of people are picking up printers off of Facebook or off of the Discord, whatever the case may be. You don't necessarily know what you're buying. You don't know, has this printer been crashed before? How many times has it been crashed? How many hours are on these rails?
What kind of rails are they?
Yeah, what kind of rails are they? These are rails that come with the Formbot kit, right? They worked fine, but they've got 3,000 to 4,000 hours on them now. They are a consumable part of a printer. Bearings are a consumable part of a printer. I had one.
The entire motion system is consumable, and if you are buying a printer off of a Facebook Marketplace, and it doesn't have to be a Voron, it could be any kind of printer, just assume that your motion system will need to be replaced. It's a safe, because that way you can kind of figure that into the price of what you're going to pay for this thing. Because you really don't know if they've been properly keeping up with the lubrication of them. Have they been running it at too high of a tension for too long, such that you're now wearing out the bearings? Who knows? So that's kind of my rule of thumb. Like, I'm going to have to replace all of this. And what are you asking for? Well, I'm not going to pay that because this is what's going to end up costing me.
I had a guy that come in that bought our H2D, our display model H2D from me. And we were sitting there talking as we were getting everything packed up and stuff. And he sat there and said, yeah, at about 6,000 plus hours on his X1C, he started getting weird prints and nothing would level. And he got to looking at it, and one of the lead screw nuts had completely, it was a bushing. It was not a nut anymore. It was a bushing. And apparently that is a part that Bamboo Lab does not sell, is a lead screw nut. So you had to go buy one on Amazon that was the right thread pitch and disassemble the bed and install a lead screw nut on the bed. I was like, oh, that's fun.
Yeah, I was looking at the ones on this, and there's a little bit more backlash on them than I would necessarily like, so they probably should get replaced as well. And it's one of those things. It's a maintenance item that as you go through, make sure they stay lubricated and stuff like that. You're going to extend the life of them, but even with all the proper preventative maintenance, you're still going to end up having to replace parts. They're going to wear out.
You have to take into consideration what parts we're actually putting in our printers, right? We're not putting in machine level grade, linear rails and all that stuff. They're I would qualify a lot of them as prosumer, a little bit better than the generic Amazon special linear rails and motion system. The belts are probably the most standardized aspect of a printer, but for what we're paying for linear rails, they're going to go out. You may have to reball them or just get a new rail for our parts on our printers.
Yeah. And like even working in manufacturing, we've got linear rails on a lot of things, and even those rails and carriages have to get replaced more frequently than you would think. I promise you're getting more time out of your linear rails on your printer than necessarily getting out of big ones that cost thousands of dollars.
But on a precision milling machine or something like that, you're those ways you're trying to keep them within tolerance. And so that's going to be the difference between the tolerance that we're doing with a glorified hot glue gun and the tolerance you're trying to get doing aeronautical grade CNC machine part, right?
Yeah. Well,
it's still pretty impressive what we can do with this hot glue gun.
Yeah, most of the stuff I'm talking about at work isn't necessarily precision milling stuff like that. It's big, heavy equipment like the linear rail carriages. They're 10 inches wide, 14 inches long, and you've got 8 of them, 2 of them per corner for a thing, but they've got tons of weight on top of it, literal tons of weight, 10, 15,000 pounds riding on those carriages, and they just wear out.
Yeah.
Yep.
No, I agree. That's why when I see some of these machines at Rocky Mountain that were on the seller's table, I was looking at some of the prices, going, that in order for me to take that, that's got to be free, because I'm going to have to put so much more money into it.
Where is the other?
You want to run vibrations and see what that looks like?
Yeah, that's what I'm looking for. There it is. Create vibrations profile.
And if any of you guys watching have any questions, feel free to shout them out, man. May not have the answers, but we'll help you as best we can.
You're hooked from your very first Flexi Rex.
You know, John, that goes into how is this your hobby? Some people want to get perfect prints. Some people just like the build aspect. And so for them, an Ender 3 that they can tweak and sit there and just play with is their hobby. That's what makes this their hobby. I don't. For me, I like chasing the unicorns and figuring that out. But if somebody wants to buy an Ender 3 or an Ender 5 and go to town, more power to them.
Yeah, it's one of those things that, like, you don't yuck someone else's yum, right? Like, and there's plenty of people that sit there and give people that build Vorons hell. Why don't you just buy a bamboo? Well, bud, because 3D printing isn't my hobby. The 3D printers are. So I have no interest in, cranking out 10,000 Flexi Dragons and taking them to craft shows. But it's okay if that's what you want to do.
100%.
So this particular calibration thing, the tool head moves at an angle. I think it's just doing one motor at a time.
So yeah, this is called vibrations profile, and when we were testing it, so Fricks it's made by Fricks, and a whole bunch of us were testing this test, and the goal is to measure indirectly the vibrations given off by the motor. And that's why the acceleration's so low. It's stuck at 3,000. And you should basically just leave it at 3,000. And what we're trying to do is get the motor up to speed, whatever that speed is on the test, as quickly as possible without inducing too much vibrations from like input shaping and accelerations. Which is also why you should run this test after input shaper and make sure that your input shaper settings are set in Clipper. So, because it relies on that to help cancel out the vibrations. And we initially was going all angles. So it started at like 0 or Y would be 90. It'd do 90 and then do like 10 degrees all around and shake it. And what we found is that you can extrapolate that entire circle just from doing the angles and, of course, some math. So that's why it only runs at 45 and 135, which are your A and B motors on a Core XY. And it will cycle through all the different speeds from, I think it starts at 2 or 4, and then goes to standard is 200. If you run faster speeds, so say you have an all-wheel drive and you want to push it to 600 or a V0 or something like that, and you want to go to 600, you should run this test twice. Once at 0 to 200, and then the other time from 0 to 600. I think Fricks is working on modifying this test to allow you to start at an arbitrary starting point. So you say you want to see what your 100 to 200 is, you can start at 100 to 200. That's being worked on, because one nice thing about this test is that one speed is not dependent upon another speed. So it's all discrete. And then it all gets put together. So the goal is to give you print speeds that have the least amount of vibration, or stated another way, is to show you which speeds have the most vibration, and those are the speeds you should avoid. But this test, either way you run it, you should follow this test up with the print test. And you can simplify your print test. You don't need all the speeds. You can basically focus on the good areas and just test those and figure out where your least amount of vibrations is in that print test. Hopefully that wasn't too confusing.
No.
One thing you will find out about this test, so when you run it enough times, is that 100 millimeters per second is not a good speed to run. You generally get a lot of VFAs at 100.
Yeah. I try most of my profiles run to 80 and then pick up again above 120.
Yeah. That 70, 80, that range is just the start of a lot of bad vibrations. And then 120, 125 is kind of like the end of the range. Luke, does that kind of match your results, or you think that's off?
No, that matches my results. Sorry, I was giggling. Mrs. Dragon dropped the whole box of prints all over the floor, so she's she's playing like, you know, pick up all the prints that she has dropped.
52 print pickup.
Yeah, I was trying not to laugh too hard, but we just printed a bunch of these little dragging token things to take to a show tomorrow. We got invited to go out to a North Carolina Adaptive Technology Program, or go with the North Carolina Adaptive Technology Program to a event tomorrow, and we're just going to be there for kind of show and tell and as a guest. And then in the September one, we're actually going to be more of a active participant, but we need to help them get their 3D printers in order, both here in Raleigh and out in Charlotte, and help them get some stuff squared away. They really need some preventative maintenance and some training, because in their own words, they were like, yeah, the printers are black. We're like, what model are they? They're black. Okay, that helps. You know, their intern that did all the 3D printing stuff is gone now, so.
I've seen that in schools in our local area, is that they give these teachers printers, but there's no real training that goes along with it. And they don't, like, I ran into this teacher in Rocky Mountain, and she's like, I'm a teacher, I'm in a local school district. They gave me this printer, they told me I had to use this slicer, and I could only use this CAD program, right? Like, she was completely locked down.
Yeah.
And she's like, I don't even know what to do. I don't, give me some, I need ideas. So I helped her find, like, she can only use Tinkercad. I don't know Tinkercad. So we went around to Armored Turtle, and then somebody at Hue Forge knew it. So we're sending her to, like, at least people that could try to help her. But that's what I find, exactly what you're running into, is that people have these tools. They know they can use them. They just don't know how. Yeah.
And we're trying to get, so our local library here in Sanford is getting ready to move into a new building, and the grand opening is May 2nd. And it's 5 or 6 times bigger than the current library. And they have a whole, like, computer setup wing, and they're going to have a makerspace wing. And we've been trying to get hold of them for the last month and a half, and we can't get them to return our calls. So we're just going to have to go over there and make our presence known. But it's like, you need to have, if you're having 3D printers, you've got a person in town not that far away that sells, services, teaches. Like, we'll come and teach our classes there if that helps, type of thing.
It's always finding that person to talk to, though.
Yeah, and I get it. They're trying to finish up a major construction project and move an entire library. They have to make sure everything's properly cataloged, boxed, moved, while maintaining operations in the old place until it, so it's, I get it. They're busy. As a small business, I get it.
Wow.
I'm normally here till 11 o'clock at night, every night.
Yeah. I work nonstop. I'm always switching out plates over there.
Yeah.
Yeah, once you find that person, and sometimes the people that you're talking to just have no clue.
Yeah.
You know, because they're not in charge of it, or they're not getting permission to be in charge of it.
Yeah.
Now, hopefully you find the right person.
Yeah, we will. We will. But yeah, we're still reaching out and getting to know different people, and you know, this assisted technology program, they reached out to us. Like somebody found out about it, they reached out to us, and we're like, yes, you know. But yeah.
Yeah, we've had the same thing with a local school district. Now they're having all this budget stuff because the COVID money's finally ran out.
Yeah.
So they're trying to figure that out. I mean, that's nationwide. But we're waiting for that to kind of die out, and then we'll talk to the director of their technology for the school district, because they did what a lot of school districts did, and they just put 3D printers in classrooms and said, "There you go."
Yeah.
And
no curriculum, no training, no nothing.
no
Go
training.
figure it out. Yeah.
You know, here's like 2 rolls of filament, and here's this 3D printer that's garbage. And yeah, good luck. And now they're throwing them all away because it was this rush that we need to show these kids, and not really understanding the technology. So we're sitting there slowly getting into them, saying, "Look, what is it you actually want to do?
Yeah.
You know, do you need this? Do you what part of this whole 3D printing or CAD or educational are you trying to do?" And that's generally the first conversation we have with them.
Yeah. Heck, even the local community college, Carolina Central Community College, the guy that runs their technology department, you know, I've gotten into the e-portal to be able to be a vendor for them, and he's like coming in here and buying spools of his own, you know, out of his own pocket because they have no budget. I'm like, oh, this sucks. You know?
So part of our nonprofit, 3D Printing Elves, is we don't just donate toys to kids. We actually give filament to schools.
Mm-hmm.
So we support the Clovis Community College and their robotics. So we're giving them PETG, ABS, all that stuff. And then we also support Fresno Unified, a couple Fresno Unified schools. And I think last year we gave away about 100 rolls. And it's for that same thing, is that they get some money for the classroom, but when they're buying filament at regular cost at retail, they don't get a whole lot.
Yeah.
Okay, so yeah, there's a lot going on in this graph. Do you want me to go through it all?
Yeah.
Okay.
Yeah.
So the polar coordinate energy profile, you want that to look more like a German iron cross. And yours, it's not bad, right? But what you can see is more like a clover. And the green areas on the polar energy profile they're always going to be your diagonals. So your 45, 135, your A and B belts. But this should actually go deeper into it, because that green area means that there's not any real vibrations there. And those are good speeds to run for around the unit circle. So you want it to be a lot sharper. Belts are probably the contributing here. Also, it could be your motor current. So you don't have auto tune installed, correct?
No, I don't think you can use that with the Ouroboros board.
No. No, I think I have to talk to. I don't know. I forget about that. But this is Ouroboros.
Yeah.
All these graphs we've been seeing are Ouroboros.
Yeah.
Okay. So on an Ouroboros machine, you can't use the recommended accels from Input Shaper.
Yeah.
They mean nothing on an Ouroboros machine, because Ouroboros has encoders on it. If this is Ouroboros, I would run this test to like 400, maybe 600, because it can do it. But the global speed energy profile, those green areas you're going to be your least amount of vibrations compared to the whole graph. And the way the calculation is done, it's done based upon the peak of that graph, right? So like peak 3 is at 4e to the 7. All the green zones are measured from that peak. And so generally what you would see here on a non-Ouroboros machine is very discrete peaks showing up. And then at the end, it would branch down like this. And if you look in the middle graph, your minimum value should kind of go like this and then cater down and then maybe start to go up at the end. But yours is not. So I would run this faster. So that's the global speed energy profile should be used for like organic shapes. So any sort of, basically most models are organic because they all have curves and stuff in them. And this takes the global energy speed profile takes care of all the curves and all the different angles. The angular speed energy profile should be very discrete peaks. One set for your AB direction, or one set for your angles, your 45, 135, and another set for 0 and 90. And you would use that for like printer parts or structural parts that have nice edges, because you can more fine-tune it on using that graph. Your heat maps, your polar vibration and vibration heat maps, what you want them to be, if they were completely orange, that would be the best, because that means that the vibrations of your motors are completely spread out against everything. Yours looks almost like that, and that's what Ouroboros will do. And then, so that means that no matter where, if it's all the same color, not black, but more like a gold or an orange, it means no matter where you're at, what speed you're printing at, it's all going to have the same vibration. Is that a good thing or bad thing? It's good in the sense that it's going to be consistent across the print. It's bad in the sense that you may have some VFAs which is why you got to run a print after this. So that's what you want to see. And you want to see in the middle vibrations heat map, I call those angel wings. You want to make sure that you have 2 complete sets. So yours, you have 2 sets, because you can see that there's at least 4 humps on the left-hand side.
Yep.
And then you get these little sub humps on the first top one, and then the penultimate bottom one, or the middle bottom.
Yeah.
And then the motor frequency profile is nothing you can do about it. It's just what the motor's putting out. There's no way to cancel out. Input Shaper would actually take care of most of that. Fricks did have a modified version that would cancel that out, but it didn't do anything, right? Because it's already been taken care of with Input Shaper. So that's kind of what this graph means. Now, if this was a non-Ouroboros machine, I would say we have some problems here. And we got to start looking at stuff, because it's not very neat. It's not a nice graph. But be that as it may, you would want to set your print speeds in the green areas. And because you don't have much print green here, you would run this to say 400 or to 600 millimeters per second and see what happens at the higher speeds.
Yeah. I do have one other graph from back when the belts were tensioned higher. And
does it look better? Because maybe I'm wrong and we should have tensioned them more.
Here's the graph from when the belts were higher.
Okay, this is better. High. So maybe because I didn't realize it was Ouroboros, maybe that makes a difference. But you can see here that I'm pointing at my screen. You're right there. You can see that it kind of starts off really low. In the middle graph, it's the red. It's the vibration metric, and how it's so much lower between 0 and say 100.
Yep.
And then it spikes up. But when you look at the minimum, the dark, what is that, purple or black? It's still really high. So you want that one to go low. You want that one to be pushed low. And then if you look at your angular speed energy profile, they're both taken off. And this can indicate that maybe you should look at your mechanical aspects of your printer, or it could just be the motors you're using. That would have an effect, because the motors. This is mainly motor driven. To be honest with you, I haven't spent too much time analyzing my Ouroboros either. It's like right there, and it's still down. But that's kind of what you're looking at in these graphs. But Ouroboros, for those who don't know, it is what is it, 70? What's the TMC driver on that one?
4671.
4671. Yeah. And it does encoders, so it can do steppers. It can do like basically a whole bunch of different motors. But right now the firmware is for steppers with encoders in it, and so it knows where the steppers are as you're moving it. And so it may be like one, I think it's in 4,000 degree increments as you go around on the what's the thing called, the shaft?
Like 4,096.
Yeah, something like that. Depending upon the motor you buy.
Yeah.
But it knows its position, and so it's a lot more accurate, and you can go faster because it will auto correct itself as it's counting up how many pulses or how far around it's gone. And so it's a lot more accurate. You can go faster. And your acceleration on that one, you need to measure with prints. But you still use input shaper on it.
So far, doing some tests, obviously I have some, like I said, issues with the rails. But what I have found with the Ouroboros board is that it very much likes to go faster because the config is running these steppers at 3.5 amps. And it's just like running like the 2804s, right? Because of the feedback current of them, you got to just push past it. And
you can run them slow. I mean, I printed PLA on them. I treated mine more like an all-wheel drive.
Yeah.
So you effectively get all-wheel drive acceleration, but you can get faster speeds with only 2 motors.
Yep. Yeah, like even with all the issues, and this warped off the bed a little bit on the corners, but even with all the issues that it has going on with it, like this is a really nice looking print. But
I mean, it does really well.
Yeah.
And it's shocking how good that the encoders are for print quality.
Yeah, so I'm really excited to see what it does once I've got some of the other issues worked out. And I think I might need to, so the mating surface on the back of that takeoff tool head, I think I might need to lap that smooth a little bit too.
Is it rocking?
It's not rocking, but it's not laying flat. Like I had to tighten it down quite a bit to keep it from rocking. So I think I might need to get out some lapping compound and lap that flat.
I mean, that's one area where plastic actually is sometimes a little bit better because it will bend and mold into that.
I had half an idea just to take and print like a 0.5 millimeter thick shim and put in there and just let it crush it, kind of like a crush washer. And I was like, I don't know if that would affect it with the angle that the belts are at. But,
that's something that I've wanted to test with XY joints. because what you'll see is sometimes the vibrations will come through or be accentuated by using metal XY joints versus when you had just plastic, right?
Mm-hmm.
And whether a little plastic shim would be enough to dampen that, I don't know, but it's something I'd want to test. The problem is you would need to have your metal XY joints formed in such a fashion that you could fit a shim in.
Yeah.
So
the other thing too I want to check out is Fabrico has that Carbonara rail, because RMG and Monolith both, the rails are mounted this way, so any expansion is pushing out and is going to cause binding going down your Y as your chamber temp comes up. So I'd like to check that out, because the Carbonara is carbon fiber. You shouldn't have the expansion issues on that.
but I see, I would, on that, my issue more is how stable is Y.
Yeah.
You know, because I can see putting a heavy tool head on it, or something like that, and then your Y movement, how much give is there?
Yeah.
I don't have one either, so I don't know, but that'd be
Hector, if you're watching, send Reth a Carbonara. Send me one too, but send Reth one for sure. You're gonna get a lot more value sending Reth one. Send Luke one. Yeah, you're already mailing Luke stuff. Just drop one in the Honey Badger.
Yeah.
Accoutrement. Yeah.
Yeah.
Send us all one. It's gonna be great.
because we saw a lot of results from the early lightweight gantries that were the skeletonized, if you will.
Yeah,
those were all just junk.
Yeah.
Just like if you put it in anything over a V0, you were going to bend it.
And then the ones that were just that were just round rods.
The what?
They had ones that were round. I
didn't see those.
Yeah.
Oh, those were the round carbon rods on the Chaotic Labs.
Yeah, Chaotic
Carbon
Labs.
fiber
That's who it was. Yeah.
Yeah, you had carbon fiber rods, and you had like 3 places where they were actually mounted to clamps around the rod. Yeah, they were on one of my printers. They're off. If anybody wants a set of carbon parts.
They're free. He'll even pay the shipping to get them to you.
Yeah.
Yeah, those ones. I just took one look at it and I went, nope. There's no way.
Yeah. All right. Well, hey, I need to drop off here.
Yep. I need to get dinner made.
All right.
Luke, Reth, thank you so very much for coming on. I hope everybody in chat learned something. And if you didn't, we'll have you on the show next time, because, we're always excited to learn. But again, if you want to dive even deeper into this, check out Reth's YouTube channel. He hasn't put out videos in forever, but I wish he would. Eddie the Engineer, do you remember him? Is he still around?
He got back into it a little bit. I mean, he's had life happen to him, family stuff, and having a family. But that's where I got into it. I'm watching his videos.
Yeah, he started on some stepper motor stuff and comparing stepper motors and everything else. It was really interesting stuff. Really knowledgeable guy. You can check out his videos. Check out Luke's videos. Always entertaining, always fun. He's on YouTube now, so we don't have to go over to Twitch, guys. He is on YouTube now. I need more of you guys hanging out in the YouTube chat, because I get lonely in there sometimes. And then, because I'm the only one, Luke ignores me and just pays attention to Twitch chat. You might just be ignoring me on purpose. It might not.
No,
it
I
might not
try
be
and pay
just
attention to all of them.
It's
But,
hard.
Yeah.
Even being a guest on your show, man, I'm like trying to keep up with it. It's hard.
Yeah. And then make sure you come back tomorrow for the Makers Making podcast. We weren't here last Friday because I was traveling out to Rocky Mountain, but we'll be back tomorrow, 7 p.m. Eastern Standard Time. It's a little bit like this. There's a bunch of makers hanging out, chatting, discussing things. I think tomorrow, if we get some makers that were at Rocky Mountain, we'll talk about Rocky Mountain a bit, what people saw, what people did. Yeah. And outside of that, we'll just do our normal squirrel chasing, I'm sure. Y'all have a great night. Take care.
Yep.
Later.
Bye all.
Bye.